Awesome. So I want to start out just by making a few announcements. And then we'll jump into the math. Number one, I do hope you all had some relaxation time over the weekend. That's like essential in order to come back and be able to start plugging away and work. So I don't know, to me, life is about balance. So work hard, relax / play hard. I think it's really important to do both. But moderation with everything, including moderation. But anyway, so that's number one. Number two, I have just a couple of announcements to make. Number one of them is all student athletes in this class. I love having student athletes in my class. I am a very physical person. I used to be a competitive triathlete and I used to run like a fair amount. So I'm all about that. And I also know you have a travel schedule, etc. What I want to say about your travel schedule and all of this related to it is, number one, I don't keep track of them, right? I have a lot of students. So I don't keep track of when everybody's going to be gone. But what I ask of you is this. So I'm totally happy to work with you. Like it's a non-issue as far as I'm concerned. Number one, if you're going to miss any class days where I'm talking, I record every class and post the recording and post the notes to the box folder, so you won't miss a thing. Just, check the recording and check the notes, and then follow up with any questions as needed. So it's not like you're ever really going to miss a class per se. You just might catch the recording. Okay. So that's one really sweet thing about running all of these things on Zoom. I'm honestly psyched to get away from that, just because I'd rather be, be bopping back and forth at the board. But regardless, that's a way that you can keep up with class notes. If there happens to be an assignment due or a test, and there's really only going to be 3 tests, so it's not going to be very often, but if there's an assignment due or a test when you're going to be gone, all you have to do is let me know the week beforehand, because I'll always let you know a week beforehand, and then we'll work out a mutually convenient day and time for you to make it up. Okay, like I'm totally happy to work with you. Yeah.
I already know the final one.
You're lucky, but wouldn't that be great if you didn't have to take it? So let's talk closer to that time,
Okay.
and then we can arrange something. I'm happy to work with you.
Okay, perfect.
Yeah, I mean, you can come to my office, hang out there, take your final. Yeah, my office is my second home, so I'm there quite a bit. Okay, so I just want to, assure anybody, and, life happens outside of school. So maybe you're not a student athlete, but, maybe you have family responsibilities or something comes up. All you have to do is talk to me and communicate with me, and I'll work with you. Okay, but if you don't communicate, that's when the problems start. Cool. Awesome. Okay. So that's number one. Number two, I got a couple emails Friday saying, hey, some of class was kind of confusing. Don't worry, I'm gonna rewind and talk a bit about some of the things that Scott discussed. So hopefully that will help. The other thing that some people emailed to me is that they had a hard time hearing because there's a lot of chatter and talk and the like. And I guess what I want to say about that is, like, I'm super glad that you're all comfortable in this class, and I love interactive classes, but it does need to be a comfortable learning environment. And sometimes people it's hard to focus, especially when it's something like math. I don't want to think about that. But anyway, I don't mind you all interact. I mean, I think it's wonderful, but do it by passing notes or text each other, just so that it doesn't disrupt other people in the class. Okay. Cool.
Yeah.
Awesome. So, yay, now I get to talk about math. Yeah, all I managed to do over the weekend, I mean, it was so smoky where I live. I still went for runs, even though maybe that was kind of stupid, but it has to happen. And, but I worked in my garden and that's like paradise for me. Yes, because it means food. So that's my exciting life. Oh my gosh, I grow so much. Well, the garlic is already all full, but I grow tomatoes, peppers, eggplants, cucumbers, spinach, lettuce, kale, chard, carrots, onions, broccoli, cauliflower, melons. I like to eat fresh greens good. Yes, totally, Sally. Thank you for that comment. All right, so what I want to do is kind of sort of pick up where Scott left off, but rewind a little bit. Okay, so here's the deal. If you have a question, as always, don't be shy, please just ask it. Okay, and if you all could let me know any questions that appear on the chat and Zoom, that would be awesome, because I sometimes get carried away with myself. So we were looking at unions, intersections, and complements of sets. And when I was here with you on Wednesday, we did some with shading Venn diagrams, and then Scott came here and did some examples using actual sets. Okay. One other thing that I noticed is some people did already go in and start the homework and had questions, and I love that. But I do want to reiterate that I don't expect you to start the homework until we actually complete a section. So, you know, of course, please ask me your questions as you have them, but I do want to say that there is a bit more in lesson one that we're going to be covering prior to me setting you loose on the online homework. Okay. So you went through those unions, complements, intersections. And again, I don't expect you to have those memorized. You want to have them in front of you because you'll just get to know them without putting on that extra pressure of thinking that you have to memorize it immediately. But what Scott did get to, and which is a really huge crux in this class, is we started talking about the number of elements in a set. That's really important. That's called the cardinality of the set. And the reason why it's called the cardinality instead of just the size is in a lot of instances, we're dealing with infinite sets, and you can't really talk about the size of an infinite set. Just so that you're hip on this, the notation for talking about the number of elements in a set is this. And again, the notation is not meant to confuse you. It's because we're lazy and we don't want to have to write any more than we need to. So when you see something like N of A, it's the number of elements in set A. Now we're going to start dealing with sets as we proceed through this class that have like 20,000 elements in it. I kid you not. Okay. Are you going to have to count them all? Well, obviously not. Okay, but there's going to be ways that we are going to want to represent that. So this notation is really quite important. And I'm not going to ask you to count any huge set, right? Like that's clearly not what this class is about. What I do want to say that that Scott did mention, which is super important, is the union rule for sets. And I'm going to write this out. Again, you don't have to memorize any formulas. You just need to know when and how to use them. So I'm going to write this out and then I'm going to draw a picture, hopefully making it clear why this works. Okay. If you want to talk about the number of elements in the union of two sets, you can call that the number of elements in A plus the number of elements in B minus the number of elements in the intersection. And again, I'm going to draw a picture. This is a formula you're going to use and need to be aware of. Okay. Essentially what this says is when you are putting two sets together, don't double count. So if I was to draw a picture, here, if I want to count the number of elements in the union, would you all grant me that the union of A and B is this region, and this region? Okay, that's something that I want you to be able to identify very, very quickly when you see a Venn diagram. Okay, when you see a Venn diagram, I want you to know that the union is all of this. I want you to know that the intersection is this overlap. Okay, that will help you out tremendously. Remember, when you take the union of the sets, you're just putting them together. You don't care what they have in common or not. Okay. There's a lot of yawns here. I love it. I feel the exact same way. Isn't it so hard to come back after a weekend? I feel it. Okay, so why does this formula work? Well, if you would grant me that that A union B is the stuff in this region, and this region, let's talk about this. Well, what we're saying is it's the number of elements in A. Would you grant me A is this region and this region? It's all of A. And now it says, okay, add on the number of elements in B. Well, B is this entire circle. So wouldn't I be adding on these guys and these guys? Exactly. But notice I've double counted these in the intersection. I counted them when I was counting the number of elements in A, and I counted them again when I was counting the number of elements in B. So that's why you subtract off the number of elements in the intersection so that you're only counting them once. From a picture, does this kind of sort of make sense, or are there any questions? All right. So, cool. What I want to do is I want to talk about word problems pertaining. Okay. I think Scott went through one of them. I'm going to go through it again. There were people emailed me with quite a number of questions. And I do want to say that I would love it when you email me with questions, or like if something wasn't clear. Being in touch with me helps. Okay, so please feel free to voice anything if you're like, I don't think so. All right. Okay. So before we get into these, I want to make a couple of comments and reminders of keywords. I say these again because they are essential, especially as we're translating word problems. So one of the key words is or. Or, recall, is associated with union, right? If I'm in the union of A and B, I'm in A or B or both. Okay? If I want to talk about the intersection, that's and. Okay? That's more fine-tuned, right? To be in both at the same time. That's typically a smaller amount, unless they're the same size. And finally, not is the complement. So having these in front of you will be very, very helpful, okay? So what I want to do right now today, and if it goes into tomorrow, is I want to go through, 1, 2, 3, 4, 5 different examples. I'm going to go through some examples where we have 2 circle Venn diagrams, somewhere we have 3 circle Venn diagrams. And I'll show you different ways of solving this. I mean, one of the coolest things about math, and there's a lot of really cool things in math, but one of the cool things is oftentimes there's more than one way to solve a problem, right? So you might take this approach, and I might take this approach, but the cool thing is we're going to end up in the same place as long as we didn't make any mistakes on the way, okay? So if you think about these things slightly different, that's cool, bring it up, let's talk about it, because multiple problem solving strategies is something really crucial. Okay? You're all so quiet. Were you this quiet at the football game?
Yeah.
Oh, I really believe you there. All right, so the first example that I want to do is, well, I'll start out where Scott left off with the rainy days. 10 days in the past month. This is not true. We're rainy. We have not had very many rainy days. 20 days in the past month were windy. 25 days were rainy or windy. How many days were both? Yeah, we could talk about it through June, absolutely. That was a great thing. My gardens were super happy. All right. So, again, I know you did this, but I want to make sure that I talk you through it just one more time to help you through the motivation of how we feel these things out. Okay, the most common comment I get when I teach is I totally get it when you're doing it, but then I go home and I'm stuck. That is a really frequent thing in math. So a couple of ways to deal with that. Number one, I talk a lot about what your thought process, quote unquote, should be, because I want to start laying those out. So you'll see that I repeat myself a lot. That's not to irritate you. It's really just so that you start getting those thoughts going through your head too at the same time. Number two, the other way to handle that sort of situation is before you do any of your homework, my number one suggestion is to review your class notes. I'm very intentional with the examples that I do in here. And what I would recommend you do is first read through your class notes. Cool. Then what you should do is copy some of the examples that we did in class on a separate sheet of paper and try to solve them without looking at your class notes. That's a real, for lack of a better term, safe space to do it, because if you get stuck, you have your class notes to refer to. Okay. From there, once you feel really good about reworking the examples that we do in class on your own and without having to look at your notes, then you're ready to go do the homework. I know that sounds like a lot of work, but a lot of work on the front end will save you a lot of frustration on the back end, for sure. Yeah.
So the other universe, whatever, is it like, so you're gonna draw that, but then like
the circles inside of it, they could be like really close to the edges because there wasn't very many days where like it didn't have one of the other.
Yeah, I mean, you're a better person than I. I don't draw Venn diagrams, like accurately to display what's really going on.
Oh,
But I sure appreciate that. And we don't even have to draw a Venn diagram with this one at all.
yeah.
We can, and I'll show you both ways. Yeah, I tend not to be very precise with my drawings. I mean, I'm lucky if I can draw a decent circle. All right. So first thing we have to do is start figuring out how are we going to write this problem out. My thing is, I always want to simplify what's being stated to me. So for example, we're talking about rainy days. I'm going to call that capital R for rainy. I'm just not original. You can call it anything you desire. And windy days, I'm going to call that set W. Okay. Now, what are we told? Aren't we told that the number of rainy days is 10? Would you grant me that? Okay. We are given this piece of information. So notice, I read through my question. There is a question that I'm being asked, but I'm not looking at that. Don't immediately try to go and solve it. Work your way there. First, work your way through the information given. So I claim that the number of rainy days is 10. Anyone have an issue with that? Okay. What can I conclude from this next statement? The number of windy days is 20. Okay. All I'm doing right now is translating. My next thing that I need to translate, which is a little more nuanced, is that 25 days were rainy or windy. What does that or tell me in terms of our set operation? Union. Good. Okay. When you see the word or, which is why I pointed it out down here. Good job, Tara. That tells me the number in our union W is 25. Now, I claim that we've now translated first, second, third. Now let's go to the question and let's figure out what are we doing now. We want to know how many days were both rainy and windy. Can someone tell me what it is that we're wanting to find, at least in terms of this notation?
The intersection.
Right on. We want to find this. Both and the intersection. Now, what I would do in this particular case is I wouldn't draw a Venn diagram. I would just straight up use my union rule. I'll show you both ways. Okay. So, and how would you know to use the union rule? That's a really legit question. By practice, you'll start seeing the patterns in these questions as you do your homework. That's the beautiful part about doing homework, is that's when you start noticing patterns and ways to solve these things. But when you have an or and you have an and you're talking about the number of elements, the union rule is probably going to be something you're interested in. So what I could do is say, all right, I have this formula. Let's plug in what we have. Do we know this value right here? Totally. That's 25. Do we know the number in R? 10. Do I know the number in W? 20. And this is what I want to find. You with me this far? All right. So I look at that. and I say, well, I got 25 on my left-hand side. I know I can add these two numbers. What do I get? 30 minus that. Now, we can go through and solve this algebraically if we feel like it. Or another way you can just look at it is saying 30 minus what gives us 25? 5, right? So I already know that my answer here is 5. Do you want me to show you algebraically how you would solve this? No. You don't? I saw some nods. So those of you who don't want to see it, close your eyes. Okay. So suppose we did want to solve for this. So I'm going to call it X just because it's a lot shorter to write X. Okay. This is going to help us moving forward in terms of solving some things later on. Do you agree that we ultimately want to know what X is? So we want X all by its lonesome on this side. Problem is we got this stupid 30 here. How do you get rid of a positive 30? Subtract it. But whatever you do to one side of an equation, you do to the other side. Do you agree 25 minus 30 is negative 5? And then those cancel and I'm left with a negative X. But I don't want a negative X, I want a positive X. How do you get rid of a negative? You multiply or divide both sides by -1. Okay, remember equations are like kids. You can't do something, give like something cool to one kid without giving it to the other kid, right? That's playing favorites. That's the way equations are too. Whatever you do to one side, you gotta do to the other side. So I'll multiply through by -1 and I get X to be 5. Yes.
So I don't know any questions like this.
Okay, so on text, I do tell you to please show all work for full credit, just in case you make a little mistake, and I can give you partial credit. Okay, do you need to show every one of these steps? No. Okay, I show every step when I'm teaching because I want to be sure that we're walking through this together. But I mean, honestly, if you went from here to there, done. Yeah, absolutely. Absolutely. I'm just showing every step because I think it's really important that everyone sees it. Are there any questions on this? All right. Do you want to see a Venn diagram? Okay. I don't think a Venn diagram is personally, well, whatever. It doesn't matter what I think. Let me show you a Venn diagram. All right. Do you agree we want to know this value here? Okay. Now, what are we given? We're given that the number of rainy days is 10. In other words, only rainy versus rainy and windy have to add up to 10. We're given that the total number of windy days has to add up to 20. Okay. Well, how can we look at this? What does the union add up to? Didn't that give us 25? So if this plus this plus this is equal to 25, but we've added them together to get 30, how many have we double counted? 5. So that's the reasoning that would go there. And that would be fine on a test too. Okay. It's just if you subtracted wrong and wrote 4 by accident and you didn't show any work, I can't give you partial credit. Whereas if you wrote this out and you just made a little subtraction error, you'd lose a half a point. So what? All right, I want to take another example. Suppose we do this on a dorm floor. Now, I'm just going through some examples. Do I expect perfect understanding after like 1 or 2 examples? Heck no, this stuff takes a while to see. Okay, this is why I do a lot of examples with you. So suppose we had this on a dorm floor of 35 people. 12 major in history. 19 major in poli-sci. And 7 major in both. And what I want us to do is take this information and draw and fill in a Venn diagram. And my hint to you whenever you're filling in a Venn diagram is start with the innermost region. In other words, overlap. Now I want to talk about my circles, about my universe, all of that. Oops. So my universe here is everybody on the dorm floor. Okay, that by default is my universe. In other words, the number in this region plus this region plus this region plus this region need to add up to 35. Okay. Now, I want you to think about what do each of these regions mean in the context of the question. Aren't these the people who major in both? Literally, they're in both my H circle and my political science circle. How about these folks here? History, but not political science, right? Maybe they're majoring in history and math. Okay, how about these people over here? Only poli-sci. Do these people out here count? Heck yeah. These are the people who live on that dorm floor who don't major in either one of those. Okay, so maybe they're an HHP major or, math. Okay, does that make sense to everybody? So what you want to do is you want to start with the innermost region precisely so that you don't double count. Do I know how many people go right in here? 7. Good, right? 7 major in both. All right. Now, this is where it gets funky, but these all turn out to go the same way. We have 12 people who major in history. Can I just put a 12 right here? No. When I say that 12 people major in history, that's my whole H circle. Okay. Some major only in history, but some major in both. So if this entire circle has to add up to 12, and I've already accounted for 7 of them, how many go here? 5. In a similar manner, a total of 19 people major in poli-sci. That's this whole PS circle. How many of those 19 people have we accounted for? 7. Therefore, how many go in this region? 12. How did we get that? We took 19 minus 7 to get the 12. Okay. So the moral of the story is don't put 7 here, 12 here, and 19 here. Number one, you'd already have more people if you added those up than are on that dorm floor to begin with. Good. Now, we're not done. We still need the people who are out here. If I lived on that dorm floor, I would be out here. Okay. These are the people who don't major in either one of them. How many people have we already accounted for? Okay, we've accounted for 24 people, right? 5 plus 7 plus 12 is 24. We're missing one number, and what do all of these have to add up to? 35. So 35 minus 24 is 11, and that's the number of people on the dorm floor who don't major in art. This is the first one we filled out together. Okay, the procedure will follow for all of these, but I'm trying to lay down the groundwork, start in your innermost region, and then work out. Okay. All right, so now we got this really awesome Venn diagram. So since we took all this time to make this really awesome Venn diagram, why don't we answer some questions about it? Okay. So what if I asked you on this dorm floor, how many people only majored in history? Okay. What I'm asking you to do now is a bit different. Now, given this Venn diagram, can you identify with each of those regions? Okay. So we want only history. That would be this portion right here. We would say 5. What if I asked you how many did not major in history? Okay. Doesn't this mean not history? Good. Cover up your history circle. How many people did not major in history? Well, these 12 plus these 11. So we would say 23 people. Right now, what I'm doing is I'm trying to show the relationship between the English and the picture. How about how many people majored in exactly one of the aforementioned majors? Okay. Notice I'm starting to use this word exactly. I'm going to be coming up with these like only, exactly. Okay. Good. Exactly one of the aforementioned majors means only history or only poli-sci. These people in the middle did not major in exactly one, they majored in 2. These people out here didn't major in exactly one of those majors. They didn't major in either one of them. Okay, so when you're talking about exactly one, it means only history or only poli-sci, which is that 17. Now, a very reasonable question to ask is, Lauren, if you put a question like this on a test, and I made a mistake filling in the Venn diagram, I'd get everything wrong, right? Okay, I'm totally hip on all of that. The way that I work grading tests, and I'll talk about it before the first test, because you will have to fill in a Venn diagram and answer some really interesting questions, is I will have you fill in the Venn diagram. That's testing one sort of skill, right? Translating from the words to filling in a Venn diagram. Okay. But if you make a mistake filling in the Venn diagram, I use your Venn diagram to grade the rest of the questions. Okay. In other words, if you got the Venn diagram wrong, you're going to lose a couple of points. But if you know how to answer the questions based on your Venn diagram, you're not going to lose any additional points. So one of the things that I'll remind you before the first test is if you just totally blank on how to fill out a Venn diagram, make up numbers and put them in. You'll get that part wrong, but you will get everything else correct, hopefully, if you know how to read it. Okay, there's a lot of good test taking strategies, but I'll remind you of all of that. So let's take one more. So suppose we did a survey of car ownership. And we asked 50 people. Suppose 30 of those own an automatic. This is almost an outdated question. 12 own both an automatic and a manual. I'm saying it's almost outdated, right? There's not too many manual transmission cars. And 20 do not own a manual. And by that, automatic manual transmission. All I want us to do right now is draw and fill in a Venn diagram. You'll notice that the information that we're given is slightly different, but let's piece through this, okay? So because I'm not at all original, A for automatic, M for manual. Yeah. All right. Given my instructions before, where should we aim to start?
Starting in automatic.
Okay, we want to always start in
Oh, well,
innermost region, if we can, okay? So notice, these are all the automatic people, these are all the manual people, these are, well, they're not people cars, anyway, whatever. And these are the people who own both. Do these people out here count? Yeah, they ride a bike or a scooter or some other thing, okay? They don't own either one. Okay, do I know the number of people who own both? 12. Woohoo! Questions there? Yeah. That's A intersect M. If you want to, totally do it. Honestly, I write your text in words rather than the symbols. Because in real life, you're going to encounter words, not the symbols. So that's what I hone in on, but I'm happy to write out the sections anytime, because it's obviously the way All right. Now, what else do we know? We know 30 people. Well, let's go down to here. 20 do not own a manual. Okay. Do you agree not owning a manual means I cover up my manual and it's this region and this region? I have nowhere to start right now. Like there's nothing I can do with it. I know that this region and this region need to add up to 20, but I don't have either one of those numbers yet. So I'm kind of out of luck at this point with this portion. Totally. So I'm going to jump up to my automatic. I know that my automatic circle has to add up to 30. How many of those 30 have we accounted for? 12. So it would be 30 minus 12 or 18. Good job. Aren't these kind of cute?
yeah.
Yeah. I mean, we could be solving the quadratic formula if you'd all prefer. Thought so. Okay, so I got that. Now can I jump to this 20 don't own a manual? Totally, because now I'm going to cover up my manual circle. And I know that consists of these two regions. And now I've got one of those numbers. Hooray! So if these two things have to add up to 20 and I got 18 here, how many go here? 2. I think it's really cute how all of this unfolds. In the next second, in the next moment, if I tell you that my dog is cute, you're probably not going to believe me. Like if I'm defining this as cute, but anyway. All right, am I done? No, I still need to find the people who belong in here. What is the one number that we have not yet used? My universe has to add up to 50. Okay. That's my total number of people. How many people have we accounted for thus far? 2 plus 18 plus 12. We've accounted right now for 32 people. But there were 50 people who were queried. So that tells us that 50 minus 32, 18 goes right here. So I want to ask you 2 questions, okay? And then we're done. But let me ask you these 2 questions very quickly. In this diagram, how many people owned a manual car versus how many people owned only a manual car? And I know this might seem silly, but I'm trying to bring all of these fine points to your mind so that you start thinking about them. So when I ask you how many owned a manual, that's my whole M circle. Good. That's the 12 plus 18 or 30. How many people owned only a manual? That is this portion of the circle, 18. Okay, so notice the word only, how that differentiates. Well, if I ask how many only own a manual, this is the only manual. I didn't double count. There's a difference between asking manual versus only a manual. I'm asking 2 different questions. So you guys, my ask of you all is A, to have a totally awesome day. B, it's also review these notes before you come to class tomorrow, because tomorrow we're going to jump into a 3-circle one and it's going to be a ball. Okay, bye. Thanks. Good to see everyone. I missed you all, honestly.